attention, please. My name's Joe Helbley. I'm the Dean of the Thayer School of Engineering, and it's my pleasure to welcome you to today's Jones Seminar in Science, Technology, and Society. Today's speaker, as many of you know, is an award-winning and internationally renowned architect, illustrator, and author, Mr. David Macaulay. David is on the faculty at the Rhode Island School of Design, where he's taught for many years. He's also taught courses at Wellesley and Brown University. He's a recipient of a Caldecott Medal for his illustrations in a picture book for children. He's been a lecturer at the TED series of lectures on technology, entertainment, and design, host of a PBS series on significant feats of civil engineering, and a 2006 recipient of a MacArthur Foundation Fellowship, which is commonly referred to as the MacArthur Genius Award. To my generation, among many of his books, he's perhaps best known as the author of The Way Things Work, one of a long series of illustrated works that beautifully illustrate complex inner workings of science, of nature, of technology, and of engineering. Just doing a little background reading last night, I came across a few quotes. I saw the New York Times has called him the Mr. Wizard of architectural history, and on the TED website, they explained that he manages to expose the world's secrets of engineering to dazzled readers of all ages. With that, please join me in welcoming David Macaulay to the Thayer School.
Thank you. Hello, engineers, friends of engineers. I feel like such a fake up here. When I sort of hear the official title of the Jones Seminar, Technology, I think, what the hell am I doing here? But anyway, I'm here, and I've thought long and hard and nervously about how I might say something this afternoon of consequence to this particular audience in this particular school. And all I can really talk about is what I've learned about visual communication through the work I do, and perhaps how some of those lessons might rub off, might be useful. Now, I have no idea how they will be useful, because I noticed that there are at least half a dozen branches of engineering. At least 3 of them, I have no idea what you do, so I don't know what kinds of problems you are solving, or how often you talk to the general public about what you do. But it seems to me that at some point, everybody in here who's working in whatever field of engineering is forced out of the lab, out of the school, out of the comfort zone of their environment, and into a situation where you have to talk to people who don't know the language. They don't know the secret handshake. They don't have the jargon. But they would like to know what you do, because they suspect that it may have some influence on their lives, but they're not sure what. And maybe you like it that way. I don't know. But I've spent 35 years now picking things that interest me, picking things that I think I would like to know more about, and trying to figure out and trying to explain them visually. So I'm just going to go through half a dozen projects, and I should explain it. Why is this up here? Because I never expected to write books about architecture, never mind engineering, subject matter, any of that sort of stuff. What I was really looking for was a career in the sort of fantasy side, the pure fiction side of children's books. And this was one of the illustrations I made to present this idea. This was the second. And the idea was that it would be about a gargoyle beauty pageant sometime in the 14th century, possibly the 12th or 13th. I made this drawing, and the editor, the man who became my editor for 30 years, until he had the audacity to retire, looked at the drawings and thought about them, and basically said, we don't really need another book on gargoyles, but I'm interested in your cathedral drawing. Why, tell me more about this. And out of that conversation came the kind of impetus to do Cathedral, to do a book about the building of a cathedral. Now, I should have been able to, figure that out without the conversation, because with 5 years in architecture, you would think you'd sort of add. But anyway, I was trying to go away from architecture. So I started immediately making pencil sketches, really quick pencil sketches, and almost always incredibly inaccurate pencil sketches. To do my presentation, I came back to him like 6 weeks later and said, okay, I laid it out on this long table and all these sketches, and I told the story of digging the holes in the ground and building the foundations and so on, without knowing really very much about it. But it was enough, and obviously my enthusiasm was there, and my hunger to see a book with my name on the cover was also there. And so this is what I mean by illustrations that are so. Here we are building the vaulting before the roof. Not a good idea. Not a good idea. Always a good thing to sort of try to hold your walls together at the top before you start putting an arch between them that's of course going to want to push them apart. But what did I know? And they didn't know. They knew less, which is hard to imagine. And so Cathedral is born, and in the original Cathedral, I say original because there's now a new version, I picked a site, a point of view, to look down on the site, because I wanted you to see the transition of that site, the changing of that site over time. And so I stayed in the same place more or less, and you gradually watch this thing go, and you end up with the cathedral, and you have that sense of having maybe been there, but my fear is you have the sense more of just being at some safe remove from the action. So I also wanted to throw in some drawings that would break this up, so you weren't quite so far away, so that you got some sense of the space and the danger involved. But still, you know, you're not there. You're not there yet. So I was given an opportunity 4 years ago. I thought it was an opportunity. I've had second thought since then, to redo Cathedral, to go back and revisit that book, to improve it, to make corrections, and to completely rethink it. So that wasn't their suggestion. The publisher's suggestion was, in fact, the request was, initial request was, would you mind if we colorized it, the original black and white line drawings? And so I explained to them that we in the art world crosshatch because we don't have color, not to then throw color on top of. You see, it's one or the other. So I said then, well, but you know what? This is you've opened the door. I'm interested in this. Why don't I just start from scratch? So I did start from scratch and did the whole thing in color, which is what they really wanted, because they have decided that the audience no longer has the patience for black and white, and everybody sees everything in color, so why not just do more color? It doesn't make any sense, actually. But so now my goal was to get you closer to the action. We're still in the air here, obviously, and you're going to be in the air for a couple more moments, but rather than that one point of view frozen on the site, I decided to make a series of images that would basically fly us around the site at different times during the construction. Snow, as you can see in that, anybody thinking about communicating visually and making drawings, keep in mind that snow is tremendously helpful for saving time. And then we sort of are in town. Now, you know, towards the end of the book, the cathedral becomes this thing in the background. What I'm thinking is people in town have gotten so used to it. They've been up there for 60 years putting this thing together. I don't even see it anymore. I've got oranges to sell and my roof to fix and so on and so forth. So that's why I completely changed the point of view and dropped this. And then we've got the beginning of the front, which is reminiscent of the very first image I made to show Walter Lorraine. But okay, in the black and white book, this was my way of dealing with foundations, and this is a holdover from studying architecture, where I speak the architecture language, or at least I did at the time as a student. So cross sections and cutaways, a shorthand way of getting complicated information across, but particularly a shorthand way of getting information you don't know much about across, but it looks technically appropriate. So there's a cutaway. All you can really see is that there's a pyramid shape, but you've got no real sense of how it got there and so on. So I decided that wherever I could in the new cathedral, I would get rid of all cross sections and go to three-dimensional drawings and try to put you there. Try to make this stuff more meaningful, more relevant, more dramatic. So you dig some serious size holes, you build some small pyramids, and you've now got a footing on which to safely build buildings that will stand for 800 years. So far, so good. Nobody, was aware of acid rain and things like that when they were building these pyramids. So there are different issues now to deal with, of course. But Another illustration or two from the black and white edition, spiral staircases were not actually built against the walls the way I've shown it here, but that is the sort of construction of a spiral staircase. Chains were not embedded in the concrete between the walls, the layers of walls. So a couple of mistakes I could get rid of. The piers were, this is a section of the pier, main piers down the nave, were not cut like that. They were solid stone, and they were put together very cleverly, actually. So in the new book, we start with the foundations. You can see the foundations are laid for both the piers and the outer wall. And you start to build the piers, and you can see how the pieces of stone of which the piers are built to sort of offset each course. And all you have to do is just keep it vertical, and you're pretty much okay. There's a spiral staircase built into the thickness of the wall where it belongs, and in the background are the pieces of tracery for the windows, which will be built into the space between the buttresses as the walls go up. And then, you know, it starts to get to the first level. And what I did was, this is how I compromised. I wanted a little bit of technical cross-section. And I wanted primarily, though, the real world. So I left the color out of the sort of diagram, because this, obviously, you can't cut a section through an arch like that and have it stand up. But by not coloring it, I'm saying it's not real, maybe subtly. Maybe it will be missed by, you know, most of my audience, but, you know, I doubt it. I give credit for that. Blowing glass, one of the things that every student in here who's done a poster knows about is something about composition, something about the journey the eye of the viewer makes as they move across this surface of information. And hopefully you've thought it through well enough so that the drawing the viewer makes is the drawing you intended, as opposed to starting in some crazy little thing on the right-hand side that actually is the least important part of your presentation. This is an example of that latter thing, where it's a complete mess. What I'm trying to do is show you the process of blowing glass to make windows and stuff, and I ended up spending much more time with it, creating a much more simplified flow of information from the furnace to the tables for the cutting, to the windows, where the pieces that are assembled you know, within the lead are then set in place in their window frames. Back to the black and white. I showed you those overviews, and I said these had to be broken up with more dramatic stuff. So here's a little sketch of being up on the roof. Here's a more finished sketch of being up on the roof. I wanted you to be up on the roof with the builders, and we're still floating a little there. We still have some kind of, we're still safe. But this one, you're less safe. You seem to be somehow much closer to the beams you're supposed to be standing on, except there's actually nothing to stand on there. And there's also a little bit of that perspective tilt, so that it leans to the right. I mean, it's all intentional to make you feel slightly sick, which I think is one of those universal reactions to a situation like this, whether it's like 800 years ago or not. But, you know, I'm losing my spontaneity as I get older. I'm not sure, I don't know whether it's supposed to happen that way or not, but I am. And I'm becoming more conservative and more determined to make these things more accurate. It's like I really want you to be able to build this roof on this cathedral now, in addition to it getting a sense of how it might have felt. So I make models more. You sort of lay it all out on the ground, you hoist the pieces up between the walls of the nave, and then you start to construct them. And these drawings of the way the beams are slotted together are in mortise and tenon fashion. These are all based on real roofs that I saw long after doing the original book. So these are details you can actually count on. And then we have to get some equipment up there, because we're going to start lifting pieces of fairly heavy stone. A great wheel is always handy. This will appeal to the sort of like the elementary physics level students here. You know, the rope around the axle is good. That's a good thing. In the very first edition of the very first cathedral, for some reason, even though I knew better, I wrapped the rope around the wheel itself. So I created, in a sense, the first medieval Cuisinart. But once you've got that device there and you can start lifting the stones up, you can start to build. And I did the sequence all in just a couple of pages. I spread it over 4 pages in the older book, but it didn't need it. And so you've got that sort of sequence following the centerings, moving from left to right, from upper left to lower right, just very logical. You want to keep that kind of information sort of intuitive, because there's a lot of technical stuff that you'd rather have people spending their time on. And then you you got your finished vaulting. Meanwhile, you have been connecting the buttresses on the outside of the aisles to the walls of the nave with centering. That centering becomes the kind of structural link for a long time, and the horizontal pieces of timber to help stabilize and so on. This is a cross section through the original, from the original book. The new version looks like this. You not only get the cross section, but you get a sense of why you need that gutter across the top of the flying buttress. That huge rain, all the rain from that huge roof sent across the gutter and out through the gargoyle mouths and down into the street below. Now, same thing with the window. I did this flat section of the window, so I played up the pattern, but more the pattern of the scaffolding, in fact, than the tracery. In the new book, I actually built some real scaffolding and showed you the stonework itself and sort of how you might fasten these pieces together, that sort of thing. And then back to another drawing in the tower, the bell tower. In the original, I wonder if yeah, see, now in the original drawing on the left-hand side, you've got guys like, I don't know, 15 feet below those monstrous bells, jumping up and down, pulling on the ropes. They'd be deaf in about 5 minutes, I would think. So anyway, I did my OSHA sensibilities kicked in here, and I built some floors and lowered them a little bit further and made the bells slightly smaller. So anyway, and the grand conclusion of the original book was this one, which was the cover drawing, and the grand conclusion of the new book is this one, which is not so dramatic as the first one. Not so graphically in your face. But I wanted to make that leap of 800 years. That's why there's a jet trail in the sky, and there's a car parked on the road, and so on and so forth. And there's no text on this page. So you've turned from 1410 to 2020. This is the first known meeting of the English and metric systems. Now, after Cathedral, a few books, I took on something that just intrigued me. Always walking past open manholes and all kinds of activity on streets and in parks and so on. And I decided to tackle the underground and what goes on underneath our feet. What is this system upon which we all depend and which we, generally speaking, take completely for granted? So a very simple approach. Peel up the street, show you the complexity of stuff, and then system by system, isolate one, show you its layout, show you how it sits in the space. Those are the foundations obviously behind. And then we can go in and take a look at that manhole with a valve. The elephant walking across the top of the manhole is simply to suggest that those are pretty strong iron structures. And then a little detail. This is the kind of detail that I would hope that readers of this book would use to sort of start asking questions like, what else is down there? Well, just turn the page, and you can see what else is down there. Now we have all these systems sort of in together, but you understand from the first image where you just pulled up the street basically and started to separate the pieces, and then gradually as you put them back together, you end up with an understanding, a clearer understanding of the larger network and the integrated nature of that network. And then we can even drop down below it if we just get rid of the dirt and join a bus tour perhaps and visit bedrock and see these buildings floating in some cases and teetering. And we can also go to Paris, which is a good thing to do, I think, once in a while, maybe more than once in a while. I don't do it more than once in a while, but I think it's still a good thing to do. Charles de Gaulle Airport, and I was thinking about these tubes as I began this project in the morgue of a small hospital in Providence, Rhode Island, where I was cutting up a brain to try to get the information I needed to do some drawings on explaining the anatomy of the brain. So this is the choroid plexus. And from this and countless, hours with Frank Netter and all these other wonderful books of medical illustration, I built a brain you need a space sort of structure, a sort of representative of the skull to get this thing started, and then you can sort of fly in over it. The thalami are under construction in the center, the cerebella at the back. If we go around to the front, you can see the right eye and the optic nerve coming out the back of it, the amygdala and the hippocampal gyrus, the paw. And then we just keep building. The whole point was this was really done at the request of a brain surgeon from California who was despondent that many of his colleagues really didn't have a clue where things in the brain were, which is not exactly encouraging if you need their skills, but nevertheless. And he really wanted, he said, let's build a brain. So that was enough for me. We were off. And opening day at the Brain Museum, and you come up the inferior horn of the lateral ventricle if you're taking the ventricular tour, and you can see the choroid plexus. That's stuff that looks like grapes and worms. That's what produces cerebrospinal fluid. And you enter this, it's a big space, and you enter this lateral ventricle. We've got one on each side, and then two basically on the center line, further back and down. The caudate nucleus is that sloping surface on the left-hand side. The caudate cafe is what I have placed there to give it even more meaning, and also to help you perhaps remember. What was the name of that cafe? I think it was the caudate, wasn't it? Yes. So, and there are different ways of traveling through the brain. You can do the Grand Canyon approach if you want, or you could just do a regular pedestrian sort of wander through it on foot. But the whole idea is to connect you with the bits and pieces and to gradually build a familiarity with the shapes and textures and so on, even though it's in black and white, which your brain actually is. That was the hardest thing about being in the morgue. Nothing was color-coded. It was really tough to leave that Frank Netter behind, but there you go. The third ventricle on the center line of the brain, that connection, that dark mass above is the connection between the two thalami, which you saw framed in the first image. Now you're seeing sort of where it is in the mass of this thing. You can go down the escalator at the back to the fourth ventricle, or you can go up to the pineal recess, which in ancient times was considered the seat of the soul, but here's just restrooms. So, and it's open late on Thursdays. So this is early work on the Grand Canyon. Now, I didn't want to do the way things work, which is an odd thing to say because I put two of my kids through college, and it was the most successful book I've ever worked on, and so on. But I just couldn't imagine spending all that time to do 400 pages on machines and physics. Physics would be involved. I don't go places where physics are involved if I can possibly help it, because I still remember high school physics. Both weeks. And, so it was more than 4. I mean, I exaggerate. It was more than 2 weeks. I'm still not sure what it was about. And I honestly, I'm a curious guy. I mean, I like to know stuff, but I have to be encouraged. And I have to say, sadly, my physics teacher either knew it really well or only knew one way of presenting it. But in any case, I did not come out of it with enthusiasm for physics. And I've borne that scar ever since, even though I know my life depends on a lot of what happens, thanks to physics. Anyway, so I said, okay, all right, let's do it. Let's try and do it and see if I can get past this little block. So these are early sketches. Now, I did I put these slides together this past week. I went back through all the old sketches and tried to reconstruct the process by which I got into that book and which sort of set the visual tone for it. So, merry-go-round, simple machine. This is all the simple machine stuff. This is where I still knew what was going on. Oh, lever, no problem. It's when it gets into electronics and stuff like that I'm really at a loss. So these are the sketches that I would do. I'm trying to organize and get my first, second, and third class levers in order and all that sort of stuff. Now I'm starting to put them together with a sort of rack and pinion kind of thing and sort of waving motion. And I'm not sure what I'm doing with this stuff. It just looks like fun. And I'm thinking maybe this book could actually be more playful than anything I remember from my physics class. That would not be hard, black pages would have been more playful than what I remember from my physics class. And I sort of made these sketches and made these sketches. And then I worked with a team in England, Dorling Kindersley, and they came up with this layout based on some of my sketches. And I said, God, it looks like a Sears catalog. I mean, who's going to read this thing? So let's go back to the drawing board. Let's let the art take up more of the space. Let's really be careful to say only what needs to be said in words. And let's make the illustrations effective enough to cover what's lost by cutting out text. Meanwhile, I was working with cave people. I thought, a community of cave people might be an interesting way to get these simple lever processes across, and maybe even all of simple machines. And so then I start organizing and so on and so forth. And it's in this drawing, this sketch, piece of tracing paper, in the center, this little bit of it, where for some reason a mammoth appeared, sort of out of the woods, who'd been watching these cave people play. And honestly, it changed everything. And I began to think, rather than just people demonstrating levers and pliers and things of that nature, get the mammoth involved in this. Not necessarily willfully, but in whatever. And how do you get a mammoth to play? Well, you stun it first of all, and how do you stun it? Well, you drop something heavy on its head. And how do you get it up high enough? You build a ramp. Oh, simple machine number one. So suddenly this thing began to go. And the other thing that happened is, once I started to draw the mammoth, I started to work with sepia ink and create these kind of fake inventor's notebook pages. So there was a look to it that was beginning to sort of evolve. And as I said, the mammoths are not always that excited about this process. And then I sort of worked backwards to cutting machines and the plow and all that sort of stuff. So here's a busy little Sears catalog page that becomes this spread, more space, where you can you pick and choose just a few things. You don't try to bury the reader under every implement you could think of that uses these basic principles. Just pick a few. Make one of them dramatic. Let it be the can opener. Or the faucet. Cams and cranks, gears and belts. Simplify. Cams and cranks, try to get those organized. Come up with some visual imagery, but it's pretty dull. So maybe try something like this instead, an egg breaker that uses those principles, that uses the cam, that uses the crank. And then the windshield wiper across on the opposite page that actually we would find useful, but it's using exactly the same kinds of principles. And then let's do the engine. Let's do an internal combustion engine. Start with some idea of how that might work. How might you spread that across the page? Since it's such a profoundly transformative invention, it deserves at least a double-page spread. But it's not a very dramatic double-page spread because we're looking sort of down on it at some kind of benign angle. So maybe we need to get sort of under it and see this. I mean, imagine this being a power plant, like the size of a power plant, a Battersea Park kind of piece of architecture with these things pushing up and down in the cylinders. And then we need some camshafts, a couple of camshafts, and we'll do this. But this one, I don't know. I didn't like it. I got angels. I've got angels in here pulling out all the stops. And so then Neil Ardley, who was my technical guru wizard, who actually could teach physics, and unfortunately for me, did, said, let's just go with a single camshaft along the side. So we went with a single camshaft. I reworked the sketches, and then went back to now the sepia ink and whatnot that I was using. And it doesn't have the tilt. It doesn't have quite the drama, but it actually creates a nice cleaner space for text on the upper right-hand corner, which is the other thing you have to keep in mind, whether it's posters or whatever it is. If it's a visual printed thing, or if it's just visual and on a screen, you need to find that balance between the visual imagery and the verbal imagery, accepting the fact that the verbal imagery is another piece of the composition. And if you don't want people to go there first, make sure it's not in a sort of leading spot. This little sketch of the early rotation on the Earth, most people don't think about that unless they live in Kansas. You can see the hand cranking there on the globe to spin it around, and it's going a little too fast, so things are flying off into the atmosphere. And it was going to be my way of explaining gears and belts and things of that nature. And I finally just used it as a title page for the first section on simple machines. And just had some fun with it. And then it sort of set up the model for the other 4 title pages for each of the sections. This is actually an illustration from the discovery of magnetic Earth. And I used the sketchbook to do my little sort of table of contents page for each of the sections, and had a great time writing it in this wonderfully florid, 19th century, 18th century way. I mean, I could just write like that forever. Not keep any friends, but I could write like that forever. Oh, anyway. And then the attack of the mouse knocking over the bottle of ink, suggesting, uh-oh, things are about to change. And that begins the 3rd section. So you're setting up this little thing all along. Not that I knew this, that these things happen kind of, a little bit by surprise. But then as we move into sort of electronics and digital, I could keep that kind of, the freedom, the feel for the X-ray machine, the scanner at the airport, or the telephone. Keeping it light, keeping it playful, keeping it engaging, forcing you to spend a little bit of time figuring out, okay, where do I follow here? But ultimately, it's not that hard. So that's how I think you win the audience over nuclear power and a logic gate park. Logic gates. I mean, it's so long ago that I even used those words. Maybe you still use them here, like chatting. Did you go through the logic gate today by any chance? Anyway, there it is. So I went to Mexico, and I went with a team of underwater archaeologists because I wanted to see what they do, because I wanted to write about what they do. And the only way to really get a sense of it without reading secondhand accounts was to be part of the team for a while. So they taught me how to use, an aqualung and a snorkel in 2 days. And then we went out, and that's me. I can see me, you can't see me. This is me from a little clip from a film that somebody was taking. And I am the one in the street clothes here, as you can see. I do not own a wetsuit. I've never really had the need to buy a wetsuit. And nobody suggested to me that it gets cold under there after a while. I said, cold, this is Mexico. Anyway, so I wore my clothes. And now the contrast. On the left, the professional. Wetsuit, 1 bubble per cubic foot. The amateur on the right, 30,000 bubbles per cubic foot, and street clothes. I used my tank in about 20 minutes, gone. And that was great because I was where I really preferred to be, which is closer to the surface. I did have the experience of trying to sort of, work around the coral without cutting my legs to shreds, and getting some sense of what it felt like to even try to drive a stake into the rock to string a chain grid. Those are things that you can see in photographs, but you can't feel them from photographs. And I wanted to try to... So anyway, I floated above them for the rest of the afternoon, drawing on pieces of acetate, frosted acetate with a pencil, number 2 pencil, and made a bunch of sketches, which I could then transfer to my own, to the illustration process, which would come later. These are the kinds of exciting artifacts they insisted on showing me. A board covered with nails, and this is a little more interesting, the sort of the tailor's kit with a piece of lead for marking the canvas if you have to repair the sails or clothing, and a piece of lead that might have been a piece of the caulking to use between the planks. And we then went to Brazil, to Valença in Bahia, to a little town where they build wooden ships still. And this is a replica of the Nina that was under construction around 1991. And it was amazing. It was amazing to get out of the car and walk through its wooden rickety gate into a place that was 500 years ago. But you're seeing the crafts and whatnot, the secrets, in a way, the results of the secrets passed down from generation to generation of shipbuilder, from the original Portuguese shipbuilders, and still being closely held And I spent this week in heaven, much of it scrambling all over the unfinished ship, measuring everything I could possibly measure, and building a model from my sketches when I got home, about 4 feet long, foam core, masking tape, pins, whatever. I wanted to be able to hold this thing and look at it from underneath, from on top, and so on. And those of you who know ships and shipbuilding and so on, I think the human body, the skeleton, is the only thing I can think of right now that's more complicated in terms of its curvature. That the ship was just, and to draw. This is all about drawing. And then I made a series of drawings based on my experience to tell the story of what the archaeologists do, the careful way in which sections of a site are uncovered, sandbags used to stop the pieces of wood from floating away once you take the weight off the wood, plans made right there on the bottom of the bed, and those plans are then collected and used to create a larger plan of the entire site so that it's all kept up to date. Encrusted iron artifacts, a formally encrusted iron artifact in which the iron is completely gone, and you're just left with the incrustation, which of course is a pretty convenient mold. So all you have to do is break into it carefully, and then you can pour resin in, and then break off the incrustation, and you've got a pretty decent set of resin shears. And then from that, I went into a full-color story, again, based on my experience in Brazil, but also using my information about that ship to recreate in the year 1600 the building of a ship in a shipyard that would be launched and would get masts and would set sail. And this is one of the great rides. And then you're in the nasal cavity before you know what's actually happening. You're trying to make the idea of digestion, starting from smell, memorable. So you want to create images. So, my tendency, and I don't recommend you do this every time you need to explain something visually, is to go larger. But so I enlarged the nasal cavity and the back of the tongue, where the taste buds are, good for climbing, spelunking and things of that nature. Teeth and a cross-section of teeth attached to a jawbone that actually moves up and down, so you get some biting action thanks to these muscles. You have to be able to move around the skull to get the best of it. It was hard to get 4 pairs of muscles in one illustration at the same time, but it's more or less there. Into the mouth, as broccoli is being crushed, and the tongue is going like this, and saliva is pouring down, and I had to really. There's not much saliva there. I know this is a dry mouth situation, and eating broccoli may be bad enough, but in a dry mouth situation, even more problematic. Anyway, eventually, with a little help, you get it sort of smushed up. And you create this little bolus, thanks to your very clever tongue. You dump it over the back and into the esophagus. And it continues on its way down with help. And into the stomach, which with its 3 layers of muscles is going to do a real job on that broccoli, plus mixing it with chemicals from the lining of the stomach. So you've got this hydrochloric acid and whatnot. Kind of a nasty mix, but it's exactly what you need before this stuff spills out into the duodenum, which is the first part of the small intestine. Now, to tone down the acidic nature of this material, you want to get some bile from the gallbladder, and you also want to get some pancreatic juices in there, so you can see the 2 pipes that would dump into the duodenum to make rafting a little less hazardous than it might otherwise be. So there's our small intestine. And if we take a look at the small intestine, this magic, like 25-foot-long hose that's got an area, surface area inside it, roughly the size of a tennis court. Hard to imagine, but the body figured out how to do that by pinching up that inner lining to create layers, and then stretching out and pulling out on those layers the villi, and then the outer surface of the villi are covered with microvilli. So each cell breaks down into microvilli. So you can see how you could get a tennis court into a hose. I wouldn't waste a lot of time trying to do it myself, but it is one of those extraordinary things. Now, you can see the sampan gliding past, only because the idea of those Chinese landscapes popped into my head as I was drawing this, and I just thought about those limestone formations, and I don't have to answer to anybody. So I could stick a sandpan in there. So into the circulatory system then, inside the villi, and then into the sort of Ruhr Valley of the human body. Here we are going between the hepatocytes and the blood flowing between the hepatocytes as we are, changing sugar, responding to messages for more or less sugar from the pancreas, as you can see here, which is producing the necessary chemicals to tell the liver what needs to be done. Into the kidneys for the waste, and the nephrons as we look down from this observation platform at this, and I couldn't draw it complicated enough. I mean, it's just so dense, obviously. But I simplified one. I sort of pulled one out, not dissimilar from underground, taking out the water system from that mess of stuff under the street once we peeled it up. And instead of the bucket, which is at the end of the system for the absolute waste once all the good stuff has been removed, a bladder is more appropriate and more comfortable. So there is the bladder and the muscles, sort of emptying it. And of course, we do have solid waste situation, which we also have to deal with. The small intestine now connected to the large intestine. The two landscapes are from either side of the Mona Lisa's head. You probably recognize those right away. A little sort of alpine Vermont kind of vista here underneath the connection between the small intestine and the large intestine. And then we move that solid waste along to the grand finale of this particular, again, drawing large has its problems, and it also has its pleasant surprises. This is a Caribou Crossing in the Alaska pipeline. And the book the book I was working on when I was invited to speak to you today, because it seemed to have some sort of relevance to the engineering community, and that I've given up on as of about 2 weeks ago because I had no idea what I was doing. It was really a book about invention, ingenuity, innovation, following timelines of basic categories, and but I was trying to make those timelines more interesting, more visually appealing, as you wander along the river or the road, which of course is changing in either case over time, along the railway tracks, which comes into the drawing. You're seeing these moments along the way. And this is a sort of cleaned up version of it. These are the kinds of things you might see along the way. Steam engines, powering pumps. Then I thought maybe I should just do some bigger categories, like talk about timepieces, clocks, and that sort of stuff. So early sketches leading to the big sort of mechanical clockwork in the tower to ring the bells. And then we've got springs and various other little devices and pendulum to improve this timekeeping mechanism. Then I should really talk about the printing press, because it really did sort of transform the spread of knowledge by making sort of democratizing of information and all that sort of stuff. And I did my movable type and that kind of thing, and the presses. But I was beginning to lose enthusiasm for this thing because it was just too much. So if you have to drain a well, which I thought was interesting, like 16th century, you got to drain the well because you need the iron and you need the coal. So you've got the pumps, and you've got animals working the pumps, and so on and so forth. And you've got Galileo and Torricelli coming up with this notion of the vacuum, or at least Torricelli, which leads us to von Guericke, who creates a vacuum with his little pump in a glass bulb-shaped thing, so that he probably invents the first useful portable vacuum, actual vacuum, in this thing with a cork in the end, which he attaches to the cylinder of this little contraption, and then a bunch of his friends, who don't know what's going to happen apparently, hold on to the rope, and he releases the vacuum, which sucks the air out of the cylinder. The piston drops, and everybody is pulled forward, and so on. So I thought, well, these are interesting little stories, but I'm not sure what to do with this. Savory comes along and creates this amazing contraption, not strong enough to actually survive under steam pressure, but it does work to some extent. It does, do a little bit of pumping, but not until Newcomen do we actually come up with a real steam pump that can be used and successfully used to drain the mines. There's Papin on the left. Papin is, I think, one of my favorite characters. He just never got a fair shake. This guy just lost out his whole life. He was always like one step behind. And, but he did build this bone digester so that it could smush bones, so that we could eat the good stuff inside bones, or poor people could. And he designed this little pressure-sensitive lock on top so that it wouldn't actually blow up, which is very smart if you're going to start playing with steam. As I say, Newcomen comes along and he actually builds this thing and it starts pumping the mines. And then I really should stop with John Shore because, trust me, it didn't work. What kept happening is, because I didn't know what I was doing, because I never actually stopped to ask a basic question, like why am I doing this, and why would you go to a book like this when all the information I've gotten and shown you so far really is online. So that real sort of, the power of self-doubt, and or just like thinking for the first time in a while. But every time I got lost in this, I would just look for more information. So ask me any question about almost anybody who invented anything of note, and some not so much, like John Shore, who invented the tuning fork. And I can hold forth for about 30 seconds on any of them. But can I make a book out of this? Not as far as I can tell. And it's only because I haven't figured out how to construct this book. So I'm leaving it. I'm going back to anatomy. I'm doing a simple guide to the Body Museum, which is a 5,000-foot high human that you will be able to visit. You will see the construction of it, first of all, which is how I will explain basic anatomy, structural, systemic, and so on. And then the second part of the book will be devoted to tours that you can take as you travel through the various systems and so on. And again, very simple, very little text, mostly visual, very playful. But I'm hoping that at the end of the reading of this thing, you actually will have a clearer sense of sort of where the bits and pieces are inside you, and a very simple explanation of what they do. The tuning fork, why the tuning fork? Who invents a tuning fork? John Shore invents the tuning fork. He must have dropped one. And it must have, either this, or it played a perfect C or something. Who knows what it was. But anyway, he was a lutenist after he had to give up the trumpet. And it just helped him tune. So, and that's another story, which gets you to the Crystal Palace and Edison and his recorder. But we'll save that for another day. So, any questions? Yes? Thank you.
My kids enjoyed your the way things work very much, but I always wondered, have you considered writing a book on the way things break? I would have to know too much. I mean, there's why they don't work, how they break, even this, why they. It brings up questions about materials, about misuse, about misunderstanding. I mean, all sorts of wonderful things. To answer your question, which I should have done, no. Every engineer really needs to worry about that.
Pardon?
Not every engineer needs to worry about that.
No, I know. You're absolutely right. And I think it's a terrific subject. I mean, what you learn from the way something breaks can be invaluable. But what's great about it to me is it opens up other doors that I couldn't even predict at this point. Where might that lead one? And obviously to redesign, to looking at the design, sort of the problem as it was originally formulated, from which this thing that has broken is a result. Was there something wrong? Did the original problem break? Was it a broken problem? I mean, one thing I learned in architecture school, I learned many, but the one thing I remember most is that without a good problem, there's no way you're going to come up with a good solution. And the other thing, of course, is not thinking that the problem you have is the problem. It's just it's a place to start, and all the other problems will reveal themselves just when you think you're in control, like with the braking. Anything else? Yes.
So I read your book until the pages were torn as a kid, so I love the work very much. I have a question though about kind of empathy as a artist. How did you put yourself in the shoes of the people who are reading your book and make sure that things made sense from their perspective? Like, do you have kids looking at your drawings and say, does this make sense? Is this clear? Or
No. No, and I don't use, I mean, I had an editor, and I work often with experts, so I talk to them a lot. And as the things get more complicated, like with the human body, I certainly went to my anatomy person and said, you know, have I got this right? I mean, but, you know, all those architecture books, I did the best I could, and I tried to make them as engaging and as interesting through the choices of perspective and point of view, and make the details, the technical details, as simple and as clear and direct as possible. But it was really writing for myself. I always have, and I probably always will. But as I take on more complicated things, I am much more dependent on the expertise of those who really know, and their generosity. What's amazing is if you present yourself as somebody who really wants to know, like a student, as I am, it's amazing how much time people will give you and how enthusiastic they will become about seeing you make progress on this and getting the word out about something to which they have devoted much of their lives. So
it's very different from like a scientist trying to explain their own work to someone who doesn't have a science background.
Right.
Because you come to it from the perspective of not understanding it and needing to learn it and then share it with others.
Well, that's why a scientist has to put himself in that position. You know, before I knew all this, you know, what if I had to sort of, what's the order of stuff that I learned? And how far back into that do you need to go? I think it's critical that you somehow are able to reestablish objectivity over the information, even as it becomes more complicated, if your job is to explain it to somebody else who needs to know it because it might impact their lives, but doesn't believe they can necessarily understand it because it's science and science is complicated, in quotes. It's a wonderful challenge. And I would love to see more people coming from sort of the science and engineering backgrounds who said, you know what, I'm going to take the time to make this information that I've been working on somehow accessible in a way that can be useful and can get people excited about, you know, what happens in science rather than run from it screaming for all kinds of reasons. Anything else?
I was just wondering if you'd ever given any thought or felt there's any market for putting your drawings on the web in things like Google SketchUp that are becoming so common, whether it's, you know, looking at a protein in a drug and you can actually rotate that molecule, or watching my son use Google SketchUp to design a glider and he can rotate that and you can rotate on the top and the bottom. So many of your drawings seem like if the viewer could do that, they could look at it from whatever perspective they wanted.
That's true. For me, seeing the finished drawing is less important than figuring out how you got there. And I certainly could never do that with digital stuff. I just don't have that kind of knowledge. If I can make Photoshop elements work, that's it. And I only use like 0.1% of what it could do for me because I'm really scared to get lost in the rest of it. But what I like is the process of drawing it in the first place, of doing the sketches that allow you to build the three-dimensional model. Once you've got the three-dimensional model and you can do this, that's fine, and that's useful. But it's much more useful if you understand how that thing got there in the first place, I think, because you had to really think about the real thing before it became this abstract version of it, this artificial version of it. So I do think increasingly about using a website to promote the notion of sketching and looking at things and throwing out problems. I would hope that there would be people who would get excited about the next step, perhaps, which would be doing exactly what you talked about, taking that information into another world, into the digital realm, and having it do other things, be able to do other things with it. But I want people to spend 10 minutes in front of something and try to draw it, try to see it. Because drawing at its best is the process of asking questions, one question after another. You don't just draw it, you're asking questions the whole time. And that's what I want to promote, because for me, drawing is my way of learning about all this stuff. And I'll draw it until I know, until I have convinced myself that I know how it works. And then I can go on to the next step, which is to create something more formal that will serve as an illustration. So I mean, that's sort of where I think I personally can be most useful.
I think you can stay for a few minutes, I believe, right, to take
Yep.
any questions if anyone would like to come down to the front of the room at the end. So would you please join me in thanking our speaker?
Thank you.